what I want to talk about today is Disco Stu, all right, and his graphs. No more about writing. Just listen. All right. The whole reason I was going over these stats thing is when we're doing after the AP exam, we have all this time to talk about current events and stuff like that, which I want to do. When we get these different topics, you're going to notice something. You're going to notice most of these guys, most of the trouble they got into had to do with the misuse, sometimes deliberate, sometimes not, of statistics. Okay? So, I want to show you, there's going to be a lot of things to talk about. Multiple comparisons fallacy, the Simpsons paradox, I'll talk about that. The Texas sharpshooter analogy. And what I like to call Disco Stu graphs. You see, stats are great at telling what has happened. Statistics are not so great at predicting future behavior, future happenings. And when you start using them that way, you really run into a lot of trouble. All right? For example, watch Disco Stu here. You ready? Hope this is loud enough.
Did you know that disco record sales were up 400% for the year ending 1976? If these trends continue, hey!
Your fish are dead.
Yeah, I know. I can't get them out of there.
Okay, that's all there is. But do you understand what obviously happened after 1976, the disco record sale? Yeah, sure. And that's the point. And that, you say, well, nobody would make that kind of a dumb mistake. Actually, they do. Turn that backlight on now. Actually, they do. You don't have to copy this down, but this is just, I'm going to use back to global warming. For example, take a look at what you haven't been watching, but the lines have been popping up on here. These are the predicted global warming temperatures by all those great models that had 95% accuracy. And there's the actual temperatures over the course of the last. And here's another graph of it too. All right, like that. If you were to look at all these models predicted, notice right off the bat they're not that bad. But as you go out into the future, not only does their variability change, but their difference between reality and them changes a lot too. Okay, so here's where we really are. That's the actual temperature over the past 30, 40 years. This is what they predicted to be for their things. I mean, obviously not really close. I mean, a couple of them maybe, but that's a lot of variability. So predicting into the future, Disco Stu graphs, that's what I'll call them, is always a dangerous thing. For example, when I was a kid in the 70s, actually even before then, if you go back into the early 1900s, I think late 1800s, a guy named Malthus originally came up with the idea, a Malthusian concept of the limited resources on a planet, and eventually we're going to overpopulate. He was just looking at the growth of population amongst humans, and we're going to overpopulate the planet. We're going to run out of resources. We're going to run out of food. We're going to run out of energy. We're going to run out of everything. He predicted that 100 years ago or more. In the 70s, it was a big deal with environmentalists. Paul Ehrlich, the population bomb. All these people predicted catastrophes. I could show you, and I will show you, and I think I already did show you partly, their predictions from the 70s. By 1990, widespread famines, millions of people dying from famine every year, not just like in third world countries because of politics, but because we just ran out of food. There's no more food left. Of course, none of that happened because they didn't predict what was going to happen to our ability to produce food. It got better. We got better at producing food. I'm not kidding you. In the 70s, there were people who said, predicted we would be out of oil by now. There were people that predicted we'd be out of food by now, out of minerals by now. Pretty much predicted we'd be out of everything by 2000. They didn't think there'd be a planet. Watch an old sci-fi movie. Watch Soylent Green. Soylent Green is an old sci-fi movie from the 70s where overpopulation was so bad, they shoveled people out of the way with bulldozers, and they ate dead people to survive. That's the entire concept of Soylent Green. They ate dead people. I'm sorry, I should have said spoiler alert on that if you want to watch the movie. Not that anybody's ever going to watch that movie, but just saying. I don't know. I'm going to go watch it now. Because overpopulation was so bad, and the resources were so scarce, we had to basically eat dead people to survive. You want to talk about the plane crash? There you go. That's what I would do in the plane crash. That's another movie called Alive, I think. Anyway, now you might think to yourself, first of all, this is global warming, and we can see already it's happening. And here's part of the reason why I want to explain. The reason why they're not that far off in the beginning, but they get further far off, is the same reason why, if you're, anybody in the rifle team in here? If you're on the rifle team, and I move back by 50 yards, you realize that my aim being off, if I'm standing right, if that's the target right here, and I'm off by 1% angle, no big deal. I'm still going to hit the target because it's right in front of my, move back to 100 yards, move back to 150 yards. That 1% angle that I'm off by the time it gets to the target is huge, and that's exactly what's happening over time. Think of that happening over time. That less than 5% error that they're saying is in their models, well, that gets exacerbated over time, even if it was only 0.001%. Over the next year, 0.001%, and over the next year, 0.001%, it becomes exacerbated over time. And that's why when you go out into the future, it's almost impossible to predict future happenings based on these climate models. All right? Take a look at this. This is a great one. This is from Australia. This is what they predicted sea level to rise by, that red line there. These are some of the other predictions. This is what it actually did. Okay, those are the actual gauges between the sea level gauges between 1990 and 2012. Their prediction, and their actual thing. All right. So, and by the way, a couple of things about this, going back to global warming and Al Gore. The actual rise was about 30 millimeters. They predicted, it looks like somewhere around 80, but I don't really know. It didn't go out into that far. Okay. So the actual rise is 30 millimeters. What did Al Gore predict in that movie? 20 feet within the next 50 years. Now, granted, it hasn't been 50 years. It's probably been, since he made that movie, maybe 15 years. So we got some gold. We got to keep going, because all we've managed to get is 30 millimeters. All right, 30 millimeters is not a whole lot. I mean, of an increase. And no one really believes that 20-foot thing that he had in his movie Inconvenient Truth. Nobody really thinks that. But even the ones that they did think are not close, because you're predicting into the future. Now, you might think to yourself that nobody going to continue to make these kind of dumb predictions, because they've been proven wrong so many times. Here is, I was just looking up stuff on population. I was mentioning about that before. This is the actual chart by the United Nations report in 2010. Do you realize this is what they actually put in their report, and it's all over the internet. You type in population prediction, whatever, you will see this chart probably pop up more than any other chart, because it's the chart for population predictions. And here's what it says. The population we predict may go up, it may level off, or it may go down. Wow. Yeah, I know, they really went on a limb there. A 2-year-old could have made this prediction, and you can't be wrong when you say crap like that. You can't be wrong because you're saying, see, I told you, it fit one of them. Well, of course it fit one of them. But to say a prediction that predicts everything, predicts nothing. Yeah, if you're predicting everything can happen, and that's one of the other problems I have with global warming. People they changed the name to climate change. They changed the name to climate change because that covers everything. Now, if it gets snowier, it's due to climate change. But if it gets hotter and drier, it's due to climate change. If you get floods, it's due to climate change. But if you get droughts, it's due to climate change. You see, a theory that predicts anything can happen, like this does, and like climate change does, predicts nothing. It's a useless theory if you predict anything. You see what I'm saying? All right, so that's one. Disco stew grass. You got to watch for that. Whenever you're given a new piece of information from the media, from the news media, I always look at everything with scrutiny. I always look at it, very skeptically. I try to look at how, they are skewing the data. But sometimes you can't tell. Let me show you this one. It's called the Simpsons paradox. It's a really cool thing. You can hide statistics, are very good at hiding the truth, as well as, illuminating the truth. Okay? I know it seems strange, but it really is. It's an old saying. I think I said this the other day. Figures don't lie, but liars can figure. This is a great example. Take a look. Say I'm doing a study. I'm in school. I'm in college. I'm going to college. I want to study the emissions of college, and I'm going to do. I'm in women's studies, and I think women are getting screwed. I mean, because they're not getting admitted correctly to the universities. That's not going on TV. I think women are not getting they're not getting a fair shake. Okay, so I do a study, and sure enough, I get absolutely I get the results I'm looking for. I look at college admissions for men and women. I study 400 women and 400 men, and guess what I find? Yep, sure enough, men are getting admitted almost 10% more. Look at, it's a huge difference. There's something going on here. I think women are being discriminated against. Okay? By the way, this is not a real study. I just made this numbers up. It shows you something about the numbers, not about women versus men. I just wanted to use it so you can see it. All right. This is the crazy part about this. If you just look at the raw reported data, you clearly get the impression that men have an advantage over women. Now, let's just say I break that data down into how I actually did the study. I studied a community college and Ivy League college admissions. Turns out to the community college that of the men and women who applied, 280 applied to the community college of the men, 200 for the women, more women were accepted than men. So I know you're going to say, okay, well, obviously the men must have beaten out the women in the Ivy League, right? And that's how. No, that's the crazy part. More women were admitted than men to the community college, and more women were admitted than men to the Ivy League college as well. Yet the overall numbers showed the exact opposite, that more men were admitted than women. How did that happen? Look carefully at the numbers. Can anybody see how that is it happened? What do you think the difference is between the Ivy League college acceptance rate versus the community college's acceptance rate? And then look at how many applied to each. What do you think?
Well, first off, you're starting off with more men and less women, and then more women and less men.
Right, but the total number is 400. So I know you're just looking at the numbers. I want you to see there's something called the lurking variable here, something that they did not report. Does anybody see what that is? Well, these two colleges are not the same. The acceptance rate at a community college is much higher than the acceptance rate at an Ivy League college. I think we all know that. Turns out more women applied to the sample I chose. More women decided to apply to a better college. They got in at a higher rate. But it wasn't enough to make up for the fact that not many women got into the Ivy League college compared to, hey, more men applied to the easier college to get into. So they got in at a lower rate. But when you add up the total numbers, guess what happens? You end up having more men get in than women because the women chose to apply. And by the way, that's just because of the sampling. Right? I didn't have to do that. If I wanted to adjust for that, and I should adjust for that, I should have had the same number of men and women apply to the same exact colleges. That's called a lurking variable, something that you weren't told about. So you didn't see it in the original data. The original data didn't show this. Those two colleges aren't the same to get into, and I should have had the same number of people applying. I told you it's not just those three things you look at in statistics. You don't just look at how different apart the means are, and the standard deviation, variability, and the sample size. There's other things you got to worry about, and this is one of them. Did you choose your sample representatively? Did you also watch and account for lurking variables where there's another difference hiding within that data like this is? Isn't that crazy?
Yeah.
That is crazy.
That's what I said.
I think so. I think it is. I mean, look at it. More men than women overall. Nuts. I know. Anyway.
Isn't that what I said? I said that.
You did it, Emily. No, I just wanted, you were just saying the sheer numbers. I wanted to see, the reason why is because the schools are different.
Yeah.